All right. Next up, we've got Yuvan, who's going to talk about BenchBot. Please welcome Yuvan.
Good morning. My name is Yuvan Pradeep. I'm a high school student at American High School in Fremont, California. I'm joined by other Thwasdev Srinivasan from the Forest Academy in UK, who unfortunately couldn't be here, and our mentor and guide from ASPCO, Ajita Kumar Venkatesan. Today we're excited to present our work on BenchBot 2.0, which is focused on automating test bench verification for VHDL designs. And this version brings cleaner code, major improvements in code structure, coverage tracking, and simulator flexibility. And this refactor isn't just the code, it's about using our best software practices to solve real-world hardware verification problems. So we've brought cleaner code, better coverage, and an expanded simulator support. Here's what we'll cover in this talk. What was BenchBot 1.0? How do we refactor using object-oriented programming principles, specifically the uses of classes and abstract methods, and then how we use property decorators to enforce designs and different contracts, our new toggle coverage, and finally our expanded simulator support, making it more versatile for different testing environments. Starting off by taking a quick look at the original BenchBot. This was written in Python 3 and built as an open source tool. The program would take in a YAML file with a designer to test, or DUT, and use it to generate 100% clean VHDL code and test bench infrastructure that includes a declaration of all DUT ports and a basic OSVVM scoreboard. And while this version worked well, aspects of scalability, maintainability, and improvability were subdued. By rewriting the code based off a class-based design, we were able to implement abstract methods and functions inside, and developers can easily implement their own different setups and custom implementations. It allowed the core code to stay the same while changes are made, and it improved code readability and maintainability, and it just overall made BenchBot easier to maintain. Moving on to how the object-oriented programming refactoring was in action. We started off with our base class. This holds shared methods that every component needs, such as how to writing the VHDL content to a file. And then we define subclasses to generate specific VHDL elements like the entity, architecture, and stimulus blocks. We can see here in our top left is our abstract base case, AFB.comp base. This includes the abstract method update case. It has to be implemented by any of the subclasses, which ensures each subclass has its own way of generating VHDL code. Then on the top right, we have AFB.entgen, which is an example for entity definitions generation. And on the bottom, we have AFB.arggen, which is an example of a multiple inheritance where we bring in architecture-specific logic from the one case and general common logic from the base class. Another aspect we've brought in is the use of property decorators in Python. Our base class includes a file name variable used to decide where the VHDL file gets named and written. But we wanted to ensure that this file was always written and set correctly, defined by subclasses, and it wasn't forgotten. So we use Python's properties getter and setter decorators. You can see this in the code on line 22, the getter, and line 27, the setter. The code snippet on the right, OFPVHF name getter, checks if the file name is set, and if not, it raises a value error. This makes sure that the file name was set, and it prevents bugs where you think a file was written, but it actually wasn't. The setter ensures a controlled and validated way to assign the file name. One major feature we added is infrastructure for automated toggle coverage for bit vectors. In VHDL verification, toggle coverage tracks whether each bit in a signal flips during simulation. So it helps identify if parts of your design are left untested or tested, and it gives you a complete verification. So in this version, compared to the first, we automated this generation of bins that tracks transitions across each switch during a loop, which you can see on line 92. So to wrap up, BenchBot 2.0 is much more versatile. We've added key features without losing the simplicity of the program. The object-oriented programming-based refactor makes the tool much easier to maintain, extend, and debug. Toggle coverage is built in, improving test quality and verification confidence for users. And currently we're working on support for NVC as a simulator to give users more flexibility in their verification pipeline. Thank you so much to our school and mentors at ASVGO, including Ajita Kumari Venkatesan and her team, who helped us on this. And we're proud to contribute to an open source project that makes test bench development easier, smarter, and more versatile. Thank you so much.
Nice work.
Yeah, any questions?
Yeah. Any questions from the audience? Yeah.
You listed the new simulator, but we're not familiar, I'm at least not familiar with BenchBot 1.0. What are the existing simulators?
Actually, I have to check that with my team. I just worked on refactoring it using object-oriented programming principles, but we had a conference at the last OR conf with the first BenchBot version, so you can definitely take a look at that, and all of the information should be on there.
Yeah, you guys came to Gothenburg, right?
Yes.
Yeah.
Yeah.
Awesome. And you're still in high school?
Yeah.
Oh my God. How does this kind of compare to what you're doing at school?
It's actually a lot different because here I don't have the libraries to actually test any of the infrastructure or see what's going on. So all I have to do is set the refactoring and then send it to the team, and then they'll test it and give it back to me. So it's a lot going on where I don't know what's actually happening. I just do it and send it to them, and then they'll send it back.
Okay. Sure. But sorry, so, all right. Why can't they just give you the tools to?
I don't have the libraries, the code libraries, so that's just for them. So
Okay.
I'll just help it and then send it over, and they can send it back.
And which language are you mainly coding in?
Python.
This is in Python. Okay,
Yeah.
Cool. How are you finding that?
It's fun. I've worked with Python a lot in the past, so
Yeah, cool.
it's pretty simple.
Yeah. Awesome. Nice work. Okay. Any other questions for Yuvan? Yeah. Phil at the back.
Thanks for the presentation. So what got you into that topic? I mean, you're in an American high school and collaborating with a British company. How did you get there?
I have one of my mom's cousins, and I was interested in their chip verification. There's the stuff that they do over there, and they just wanted a bit of help, so I wanted to help out more.
Cool.
Yeah.
Do you get like extra credit at school for this or something?
No, I wish.
Oh, what? That's unfair. Cool. All right, we'll leave it there. Thanks again, Yuvan.
Yeah,
Appreciate
of
it.
course.
Cheers. Nice work.
Yep.